I think I was muted there. So hello, welcome to the class on chemical reactions, key stage 3. So I'm Laura Lewis. Welcome to the class. I think I was muted in the first bit, so you didn't hear my name. Just make this a little bit bigger. Okay, chemical reactions. So we're going to look at number 1, an overview of how chemical equations are written and the use of state symbols. Number 2, a description of how to write chemical equations. Common chemical reactions such as corrosion, neutralization, and combustion, because they're the ones you'll come across most often. And number 3, an introduction to the idea of balancing equations. That comes a lot in GCSE, so it's preparation for that. Okay. So you have two. You can have two chemicals reacting together or one breaking down. Okay, so you get two different things to break down. But the main point of this is that when you're having a chemical equation, the atoms just rearrange themselves. Okay, so zinc carbonate, okay, so is a white powder. If it's heated, it breaks down to zinc oxide and carbon dioxide. Okay, so you can have lots of different types of reactions that we're going to talk about. Okay, so this is called actually thermal decomposition. Okay, so if you heat something, it breaks down. So we see lots of different ones. So we've got zinc carbonate, okay, ZnCO3, so it's got zinc, carbon, and 3 oxygens. If you see a capital letter, it's the start of a symbol for a chemical element. So Z, capital Z, small n, so that's 1 zinc. Capital C, so that's carbon, capital O is oxygen. And the little number means it belongs to the oxygen, so there's 3 oxygens. So it goes to, is how you say the arrow, zinc oxide, okay, just 1 zinc and 1 oxygen, and carbon dioxide. So nothing has been added here, it's just decomposed. So basically you get out what you have in the first place. Okay, so that's very important in chemical reactions. Nothing sort of magically appears or disappears. It has to come from somewhere. Okay, so that's one thing to get used to. So yeah, this is reiterated about conservation of mass. It sounds more complicated than it is. So all this means is states in a chemical reaction, the total mass of the product, so what's made product, is the same as the total mass of reactants, so the things reacting together. So atoms do not magic out of nowhere, and they're never destroyed. So they have to go somewhere. Okay, so they don't just disappear into thin air. Okay, so yeah, so that if you put the two things on the scale would weigh the same as, I wonder if I can write on this. Oh, yes, I can. Yeah, that's my plan, was to write. So let's just change the, okay, so I've got like a little graphics tablet here. So if you look at the salt and the water, okay, together, okay, if you dissolve it, you'll still get 180 grams. Okay, so these two things, yeah, it has to go somewhere. Okay, so example, you could, so this is a chemical reaction now. Let me just see if I write on the next slide. No, I'll write it on here if I haven't written it on the next slide. Okay, so what we're doing here is we're burning magnesium. So you might do this in class. It's quite a common experience to do at school in class. So you actually have some magnesium. It's called a crucible. This thing you burn it in. Okay, and you measure the crucible and the magnesium, 6.81 grams. You burn it. Okay, so set it alight. Magnesium is metal, so it's a metal that can burn. Afterwards, it looks like it's increased in mass. So what has happened there? Okay, so let's think about that. So we're getting into combustion. Okay, so combustion, and we'll go over it again a bit later, is a metal or any other substance, in this case it's the metal, reacting with the oxygen in the air. Okay, we're going to start, so Mg is magnesium. Okay, magnesium. Okay, O2 is the correct way of writing oxygen. So oxygen hangs around in pairs in the air, so it's O2, but that phone network, if we can remember that, goes to. Okay, so you don't write equals like in maths, you goes to. Okay, and what's formed is magnesium oxide. Magnesium oxide. Okay, so when something's burnt, so or combusts, it reacts with the oxygen in the air. So if you burn wood, is reacting with the oxygen in the air. Okay, MgO. Okay, and yeah, you're going to start introducing to state symbols here. So magnesium is a metal, it's a solid. So S for solid. Okay, let's write this up here. Small s. Just be careful you write it. You have to write it down the bottom like I just wrote it. It's a solid. Oxygen we know is a gas. G for gas. Quite straightforward, this isn't it? G for gas. Okay. Magnesium oxide, you can see it in the bottom there. It's a solid. It's a powder, but it's still a solid. Okay, so we've already written that. It's a solid. Solid gas. There's two other ones you might come across. L for liquid. It's actually quite unusual to come across that. Most things, apart from water, are a solid or a gas. So liquid would be water, and some rarer things like mercury. Okay. AQ is actually a common one as well. That means aqueous. Aqueous. So that would be something dissolved in water. Okay, that means it's dissolved in water. Okay. That's actually a very common one. So lots of things are dissolved in water that you probably don't realise. Things like acids and alkalis would actually be aqueous. We've come across that a lot, aqueous, dissolved in water, etc. Okay, we'll do more examples. Okay, so let's start to answer this question. The magnesium gains mass after you've burnt it. The reason why is because it's reacted with the oxygen from the air. Okay, so the answer to that question. So it's reacted with the oxygen in the air. So the oxygen came from the air. It didn't come out of nowhere, it came from the air. It was always there. We're breathing it, aren't we? So we know it's actually there. So with the oxygen in the air. Okay. So it's a good thing obviously to copy these down. The best way of learning something is just to copy it down and to practice. Okay, so this is actually combustion. Okay. So one form of combustion. You'll find other forms a bit later on. Okay, so we've got another reaction. There's obviously a warning on this. You do this at school. Acids are dangerous. Okay, I always put warnings on things. So you may do this one at school. It's quite a very common one again to do at school. Okay, this is actually a neutralization reaction. It's one type of neutralization reaction. So we have so open containers. So chemical reactions involving open containers appear to go against the conservation of mass. Okay, so that's very important here that the container. This is a flask. Okay, so it's called a flask. So they seem to go against conservation of mass. Seem, okay, or appear. They don't actually, so nothing does. So this is when the mass appears to increase or decrease after a chemical reaction. Okay, so like earlier on the magnesium, let's go back one. Magnesium seemed to increase, but really it wasn't. There wasn't anything magical going on. It was coming from the oxygen in the air. Okay, so in this case, calcium carbonate, also known as limestone or chalk, okay, like the rock, is actually what's called basic. So it's alkaline when dissolved in water. Okay, hydrochloric acid, obviously an acid. Okay, so we have the calcium carbonate. Okay, sometimes you put cotton wool just over the top so the liquid doesn't come out. Okay, you don't need to do that, but it's more of a safety thing. So it's about warning open containers. Okay, see acid dangerous. Okay, so we've got hydrochloric acid and we have some calcium carbonate chips. So like little chip, like if you've got a rock and chipped it, or a piece of chalk. Okay, and chipped it. So 103.2 grams. It fizzes, it reacts. You'll see a reaction. Okay, if you do that, and fizzing stops, and it appears that the mass has gone down. Where has it gone? Okay, oops, sorry, let's go back one. Where has it gone? So let's look at the reaction with this one. I might get my whiteboard up. I haven't got enough room, but I might have enough room up here. Okay, got a spare whiteboard. So we've got calcium carbonate. Calcium carbonate. Okay, so that's that chalk reacting with hydrochloric acid. Okay, so let's write the state symbols underneath. Okay, so we've got let's write this is the chemical equations first. CaCO3 is calcium carbonate. A bit like the zinc carbonate we saw earlier. Calcium carbonate. And that is a solid because again it's chips or powder you could have it in. Okay, but it's actually solid still. People make that mistake of thinking it's something else. Okay, so let's have hydrochloric acid. So HC, capital C, small l. Okay, hydrochloric acid. So and that's aqueous. So we talked about earlier, aqueous, AQ, aqueous. Okay, it goes to. So it's a little bit more complicated. It goes to here. So you have calcium chloride. So let's write the words first. Calcium chloride. Calcium chloride. Water is produced as well, because this is a neutralization reaction. In neutralization reactions, you always have water being produced and carbon dioxide. See, this is going to be the telltale of why the mass has gone down. Okay, so I'm going to write something underneath here. Calcium chloride is CaCl2. Aqueous, it's actually still dissolved. Aqueous. Plus water. Oh, that's a liquid. So we've got an unusual one. L for liquid. Plus carbon dioxide. Okay, gas. So why has the mass gone down? Okay, so if you think about it, the calcium chloride is aqueous, so it's still in solution. Water is water, it's not going to get out. But what's going to escape, because this allows gas to escape, is the carbon dioxide. Okay, carbon dioxide has escaped there. Okay, that's what's caused it to appear to have gone down. It hasn't really, it's escaped into the air around us. Okay. So we're going to look at corrosion. So we're going to get my whiteboard up. I don't need those anymore. Okay, so I'm going to get my whiteboard up. I need to move this. This is in the way. Okay, my whiteboard up. Okay. Right, so corrosion. Let's talk about that. So it is a metal reacting with oxygen in the air. Okay, so you have a metal like iron, goes, say plus, let's say plus. Let's rub that out for a bit. Iron plus oxygen goes to iron oxide. Okay, so what symbols to that? Iron is Fe, solid, room temperature. Oxygen, O2, iron, gas, Fe, O2. Okay, so we know rust is a solid. Okay, so yeah, the iron's got its own special name for corrosion. It's called rusting. So corrosion in iron. So all metals can corrode, apart from gold, silver. Corrosion in iron has got a special name, rusting. combusting. Okay, so it's quite a slow reaction, corrosion. Okay, let's just zoom out a little bit. Let's go over another one. Okay, got corrosion. Right, combustion. Okay, so some people may have gas, okay, in their house. So let's see what that is. So gas is methane, okay, and it's burning to produce carbon dioxide and water. Okay, so let's go to the whiteboard. Go back to the whiteboard. So corrosion, let's just get rid of that for a minute. Okay, let's look at combustion. Oh, here's my pen on. So combustion. Okay, so things that occur in a house. So if you, methane. Okay, plus it has to burn oxygen. Combustion is all about burning oxygen. Goes to carbon dioxide and water. Okay, so let's have a look at the equation. CH4 is methane. O2 is oxygen. So these two are gases this time. Okay. Carbon dioxide, CO2. Okay, it's a gas. Plus H2O, water. Okay, so it's liquid. Okay, so we can start sort of look at balancing an equation here. We need to look at a number of things on each side. So there's one carbon here, one carbon there. There's enough carbons, 4 hydrogens here, 2 hydrogens. Okay, so that's not balanced. So let's write this down. So carbon 1, so I'm going to go to a little divider here. Okay, hydrogen on this side. There's 4. Hydrogen at the moment on this side, only 2. Oxygen, 2. Oxygen, 2. And 2 here, and there's 1 here. So yeah, we need to have a look at that because there's 3. It's not immediately obvious. Okay, so let's try and sort out one at a time. So let's try and sort out the hydrogens. Let's put 2 in front of here. You can put numbers in front, but you can't change these. You can put them in front. Okay, so that gives us now, that changes a few things, doesn't it? So it changes, we've got 4 hydrogens here, and now we've got 4 here. So this goes over here. So cross through and put 2 there. That now gives us the same amount on both sides. So we've balanced that equation. Okay, we've balanced this. It's quite a hard skill to get. Okay, so it's just a preparation for GCSE. It's what people find it the hardest topic is balancing. Okay, so last one we're going to look at. We're going to look at neutralization reactions. So you have an acid and alkali. We need to look at a little bit of one. So a neutralization reaction. Okay, what I can actually see. Right, neutralization. So it's an acid and an alkali. So the general form is an acid plus an alkali. Goes to a salt, okay, plus water. So a salt is just something that's produced from a neutralization reaction. Okay, so let's look at a classic one. So we'll have hydrochloric acid. Okay. Plus something called sodium hydroxide. Okay. But I won't write that what equals at the moment. You can have a think. So HCl, we saw that before, aqueous. Acids are aqueous. Sodium hydroxide, NaOH, also aqueous. Okay. So acids and alkalis that we said before are aqueous. Can zoom out a little bit. Okay, so they produce, so we can actually think about this. We have to produce water, so we know that. So something plus water, H2O. So we actually produce, so the H and that, so that H and this OH is gone. So we actually produce sodium chloride. Okay, plus water. Okay, so this part and this part match together to form this. And let's change my colour. This and this match together exactly to form water. Okay, so I didn't put the state symbol. So NaCl dissolves in water, so at that moment it's aqueous. Okay, and this is sodium chloride. Okay, so that is a salt, and sodium chloride is actually the same salt that you put on things like chips and roast potatoes. Okay, so you can get other salts being made by other acids, but that's a good introduction. Okay, this is balanced. So you've got one hydrogen, two hydrogens, one chlorine, one sodium, one sodium, one oxygen, one oxygen. So it's actually balanced. You don't always have to change an equation to balance it. Sometimes they're already balanced. Lots of neutralization reactions are quite easy because they're already balanced. Okay, so that's all for today. This introduction to chemical formulae. Thank you for listening. I hope to see you in another video. Goodbye.